Okay, so this example states that two objects are connected by a weightless cord, so that we're ignoring the weight of the cord itself, and it's wrapped around a fixed cylindrical surface. The coefficient of static friction between the cord and the surface is 0.3. One of the objects weighs 100 pounds, as shown, and the other has some weight, W. If the system is initially at rest, we're supposed to determine the range of values for W where there is no motion. So we're going to be looking at impending slip. So the question is with this, it talks about the slip, right? So is this weight going to slip upwards? So if that 100 pounds is significantly heavier, so the T2 side is the 100 pounds, this will raise up. But if I put enough weight on this side, I could actually bring that 100 pounds down, right? So the question is, which direction does this go? So we need to kind of look at both cases for this. So let's say if the downward motion of W is impending, then T1 is equal to 100, and T2 is the high side of it. So if we look at this, we're saying W moves downward, right? So W is downward. That means T2 is equal to W, and T1 in our equation is 100. That's the low side, right? If you remember, our equation is T2 equals T1 e to the mu beta. All right, let's go back here real quickly. We see that our mu is 0.3. So we know that mu equals 0.3. Beta, if we look at this, right? It is going directly across. 2 pi is the full circumference, so beta is really just half that, or just pi is what we'll be looking at. Okay? We can plug this into our equation. We say 2 again is equal to W. T1 is 100 pounds. E to the 0.3 times pi. W equals 257 pounds. So that's one scenario where W would move down, right? This W would move downward. Okay? Now let's look at the case where this W actually moves. This W moves upward, right? And if that's the case, so we want W moves upward, or impending to move upwards. What that means is that T2 is our high side, or 100 pounds. T1 is equal to W. We have the same mu and we have the same beta. We can plug this back into our equation. Remember, the equation is T2 equals T1 e to the mu beta. T2 is 100 pounds. T1 is W, e to the 0.3 times pi. And we can solve for W. W will equal 39 pounds. Okay. So our range for this is W is greater than 39 pounds and less than 257 pounds. Right? That's our range for making this thing not want to move, right? If it equals that, then it's going to move. Of course, there's some coefficient of frictions that may be off a little bit, so we may give ourselves some leeway in this and maybe make it, 43, 45 pounds up to 250 pounds or something like that would be a safety factor that we might put in as engineers. All right? So that's always something we need to look at, too, as our safety factors for everything. If you have questions on this, please let me know.